Okay, so we're going to start with division of fractions today, and I thought that I didn't really want to start it today with having spring break next week, but I want to go ahead and get you introduced to it. So what reciprocals are is it's a special way that you have to do a fraction in order to divide. So a reciprocal is basically the opposite or the inverse when you switch a fraction around. So two numbers with a product of 1 are called reciprocals of each other. So if you write 2/7 and 7/2, those are reciprocals. That is because 2 times 7 is 14, 7 times 2 is 14, and it equals 1. So the reciprocal is basically just a flipped around fraction. When we divide fractions, there is no division really. Basically what you're doing is you are flipping the fraction around and then you're multiplying. So there is no difference really except for this reciprocal. So that is what a reciprocal is. So put that in your journal, and then I'm going to give you the steps on how to find the reciprocal. There's a certain way to do it, whether you're doing a fraction or a whole number, and it is easy, but you guys have to remember to do it each time, because if you don't do it each time, then you're going to get the wrong answer. So I'm going to clear this. So look at your book on page 214. To find the reciprocal of a number, you write the number as a fraction. Okay, so step 1, write as a fraction. Step 2 is invert the fraction. And invert just means to flip it upside down, basically. And then step 3, you check. You don't have to check like by rewriting it and all that. You can check it in your head. You'll know if it's the inverse by checking it in your head. So I'm going to get you to write that down, and then I'm going to show you the examples of what they mean by this. So in your book, it says find the reciprocal of 2. 2 is a whole number, so it's a little bit different. So that's why you have to make 2 a fraction first before you can make it a reciprocal. We're going to do this, practice some, and then I'm going to do your notes with you for science, because you did the vocab yesterday. And then you're going to read the lesson today and do the 1 through 5. And I'm going to go ahead and do your notes with you in class on this. That way you can have that done, and I can kind of talk about it with you as we go over the different kinds of rocks. And you should have done this in 3rd grade. I don't know quite if you did or not, but should be kind of familiar to you. All right, so if we want to make 2 to an inverted number, we have to write 2 as a fraction. So remember, to make a whole number a fraction, you put it over 1. So that's step 1. We'll put a little check mark here. Step 2, invert the fraction. So I'm going to make this green. If I invert the fraction, I flip it over and put the 1 on top and the 2 on the bottom. Then I check. So if I wanted to check, I can do it by doing this. 2 times 1 is 2. 1 times 2 is 2. And that equals 1. So 2 and 1/2 are called reciprocals of each other. So all you're basically doing is flipping it upside down. That's it. But if you have a whole number, you have to make it into a fraction before you can flip it upside down. Okay? So I'm going to put a blue check where we checked it there. So that's how you do the invert or the reciprocal of a whole number. So I'm going to show you your classwork today is going to be 13 through 18. So we'll do some at the bottom to kind of practice. I didn't give you the bottom ones, 1 through 12, just because I think they're kind of confusing the way they worded them. But we can do it as some practice. So I'm going to scroll through and see if anybody's still writing. Remember, I'm recording this, so I'll post it to YouTube, and then you guys can go back and look at it too. So if you just got in, don't worry if you didn't copy it all down, because I'm going to go back through, put it on YouTube, and you guys can check it. All right, so if I have a number like 7, and I wanted to find the reciprocal of 7, first thing I would do is put it over 1 to make it a fraction. Then I flip it and put this number here and this number here. So then I get 1/7. Okay? So that's all there is to it. What I'm going to get you guys to do is I'm going to put a number up, and I want you to write the reciprocal. Then I'm going to go through, and I'm going to unmute someone to give me the reciprocal. So I'm going to write the new one in red. Give me the reciprocal of 3. And then I'm going to unmute somebody and get you to tell me. All right, let me get Braylon. I see her hand is up. Braylon, you have a question?
Yeah, I had a question about the reciprocals. So can you do this for just about any of the numbers?
Yeah, you can do it with mixed numbers. You would have to change it to an improper fraction first. You can do it to anything. So good question. I'm going to show you guys how to do the mixed numbers in just a second. All right, Braylon, do you have your answer?
Yeah, I do.
What'd you get?
So if you do, we're doing reciprocals. Okay, so you put the 3 over a 1,
Mm-hmm.
and then you multiply, and then you make 1, and then you invert it and make it 1 over 3, and then multiply it to make it 3 over 3, and then 3 over 3 equals to 1.
Good. So that's how you check it. So your final answer of your reciprocal, so what I would want on your classwork is 1/3. So you guys make sure that you're not doing it too quickly and you're taking your time. 1/3 is your answer. Good job, Braylon. What was I gonna say with that? I totally forgot. Let me show you how to do a mixed number. Let's do 5.5. So what you would do is change it over to an improper fraction first. So 5 times 2 is 10, plus 1 is 11 over 2. So my reciprocal, we can put r equals if we want, is 2/11. You don't reduce these because then it makes a completely different number. That can't be reduced anyway, but you don't need to reduce any of these reciprocals. All you have to do is flip them over, and you guys can do this in your head mostly. Just make sure that if you are doing it in your head, you're completely sure of it. All right, so I'm going to give you another try. If it ends up as an improper fraction, so if I end up with something like 7 over 2, keep it. You don't need to change it into a mixed number here. You can keep it just like it is. So if I give you guys 11/12, make that into the reciprocal. And then I'm going to come through and show you, well, I'm going to unmute and get the answer. All right, let's see. Dylan, what did you get for your reciprocal?
12 over 11.
Perfect. 12 over 11. That's all you would put. You don't need to do anything else other than that. So I'm going to give you a couple to try on your own. I want you to do these in your journal right now, just like we would do in class. I want you to write the reciprocal of each one of these. Okay, so number 1 is 7/3. 2 is 4.5. 3 is 5 2/7. So give me the reciprocal of the numbers there. I gave you the harder ones because if you guys can do these, you guys can do any of them. So I give you a minute or so to do these. One thing I noticed on the tests that were turned in yesterday, pretty much everybody knows how to turn it into a improper fraction, the mixed numbers that was in the last page of your test. Some people got it wrong though because they were going too quickly and they didn't add it right, or they didn't multiply right. So just make sure that you're taking your time on that, because that was just silly mistakes yesterday for a lot of people. Some of you I sent messages to last night about making some corrections on your test. So if you haven't checked your messages yesterday from that assignment, you might want to check that. It was kind of either or. Either you did really well or you did really bad on it yesterday. And a lot of it wasn't that you didn't know how to do it, and it was that people forget to turn things back into mixed numbers or to reduce. So everybody pretty much knows how to do it. It's just that we need to make sure we're reducing and turning things into mixed numbers. Be about 1 or 2 more minutes. Carolyn, you have a question?
Yeah. I should probably ask this after you give us the answers.
Okay, you want to wait and see?
Yeah.
Okay. Addie, you have a question?
Yes, ma'am.
Okay, go ahead.
My question is, when we do, for homework, are we gonna have to like check it, like put it to 1?
No.
Or are we just gonna put okay.
Yeah, you can just give me your answer for that, and that's fine. Let's see. Let me look at who has raised hands. Christian, you got a question?
Yeah, so for the test, are we gonna see this? Because this is like kind of easy.
Yeah, so
Right.
you'll do this, but then this also builds into the division. So when we start dividing after spring break, you will do this first and then multiply it to get the division answer. So there
Yeah.
really isn't dividing like you think about when you think of like 6 divided by 2. It isn't like that. It's basically you flip it, you multiply, and get your answer. So you have to do this first before we can learn how to divide. All right, so I'm going to go through, solve these for you. You check yours. So 7/3 equals 3/7. That's your reciprocal. You're just flipping it over. Now 2 and 3 are mixed numbers, so it's not going to be as simple as flipping it over. We have to change it first. So if we do 4 times 2, that's 8, plus 1 is 9. So if we have 9 over 2, to make that a reciprocal, we do 2 over 9. So for your mixed numbers, you first have to change it over into an improper fraction, then flip it. So same thing for number 3. 5 times 7 is 35, plus 2 is 37 over 7. So to make that into a mixed number, I mean not a mixed number, a reciprocal, we just flip it, 7 over 37. Okay? So those are how you do reciprocals. So what I'm going to do is unmute you guys in a second, see if you have any questions. If you don't have any questions, you can get your science stuff out. If you don't have any questions, limit your noise too so I can see. Actually, let's just do this. If you have a question, raise your hand on the thing and then I'll unmute you one at a time. If you don't have a question, get out your science stuff. All right, Braylon, shoot.
I actually have 2 questions now. So when we first did it, we did the equals out stuff,
Mm-hmm.
the multiplication. Do we still do that when we have a test on this?
No, you don't have to. That was just to show you how it works.
Oh, and also, so are all of your reciprocals always going to equal out to 1?
Yes. Mm-hmm.
Okay.
Every time. All right, Christian, what's your question?
Oh, I forgot to I forgot to put my hand down.
Oh, okay. All
I'm
right.
sorry.
Addie, do you still have a question?
Sorry, I forgot to put my hand down too.
Oh, that's my fault. It's fine. All right, let me. All right, Braylon, question.
No, I lowered my hand, didn't I? I lowered my hand.
Oh, okay. Anybody else? I don't think I see any. Okay, so this is pretty simple. We'll practice it some more after spring break too, before we go back into really getting into the division stuff. So I'm going to clear the screen. What I want you to do is have your journal open for science or wherever you're going to write your notes. And then we're going to do that, talk about it. Hopefully my handwriting is okay for that. Actually, I don't even know if I have my notes for this. I think it might be at school. Give me a second. Let me look in my book bag. Let me see if I have the notes for that or if it's at school. I might have
Hey,
left
Ms.
it.
Clark,
Yes.
can are you still gonna post out that thing where you have our are you still gonna type it up like you do?
I might have to if I don't have them here. So let me check and see if I have them.
I mean, like type them up and post them on Shelby for people who are
No, I'm recording the video.
Oh,
Okay, so I don't see them here. So let's just look in your book. I might have to wait until after spring break for that because I definitely left them at school. I guess I didn't think that we would be doing this long. So look in your book, C36. If you don't have your book with you, you can just kind of listen. Gabrielle, you have a question?
This is about the moon, though.
Uh-huh.
What else can you use besides conditioner?
I don't know. You could try things and just see what works.
Because we didn't have cornstarch, so we replaced it with the stuff you use to make mashed potatoes.
Uh-huh.
But that didn't work out, so we're trying to figure out how to work with what we have.
I think you can make it with flour. Like flour.
We don't have flour.
I don't know. Google it.
Because we looked up what you were able to replace with cornstarch. It said mashed potatoes, flour, and other good stuff.
I don't know. I think when we were little, my mom used to make it with flour, and it would work.
so wait, so you can use flour, but then is it like what else did you use besides flour?
I don't know. We'll have to look that one up.
Is that like conditioner that you use?
Yeah, but we'll have to look that up after.
Yeah, we tried using conditioner, but we didn't have enough.
All right. Let me see. Let me get some questions real quick, and then we're gonna get started. Dylan, you have a question?
What page is it?
C36. C36. Braylon, you have a question?
So as we read along, can we take our own notes?
Yeah, sure. Go ahead. That's perfectly fine. All right. Let me see. Jaden, question?
Yes, ma'am. On the left, like science, one that we had, you didn't answer my question about like the plates floating on the magma.
Where did you write the question?
Visual Google it.
Oh, yeah. Okay. Remind me at the end of this, and I'll look. Okay. Let's see. I think I got all the hands raised. All right. So look at C36 with me. So we're going to kind of glance over this because you guys are going to read this today as part of your lesson. So look at the first part. To be a mineral, a material must have certain features. A mineral is always solid with particles arranged in repeating patterns. This pattern is called a crystal. Almost all minerals are made from material that was never alive. Also, true minerals only form in nature. They're not made in a laboratory. So I am going to write these three down because you do need to know these. If you don't want to write these down, you want to wait, that's fine. But to be a mineral, it has to have three things. It has to be formed in nature. So it's not going to be the kind of diamonds that you have now that are formed in laboratories sometimes. It has to be formed in nature to be a true mineral. It has to have particles in repeating patterns. And then it was never alive. So this is not going to be anything that was fossilized or anything like that. It's going to be stuff that comes from the earth that was never alive. So the three things to make a mineral: it has to be formed in nature, the particles are repeating patterns, and it was never alive. Okay, so these aren't going to be your actual notes, but these are three things that you do need to know because they're super important. So I'm basically going to kind of preface the chapter or this lesson with you, and then I'm going to let you read and answer the questions on your own today. So I'm going to leave that up for a second if you're still writing. I'm just going to kind of glance through this. If you look at the book, it has different kinds of minerals at the bottom, and what we would normally do in class is I would show you these and we would kind of explore these. Unfortunately, we can't do that this year. So one of them, they show you in the middle of the reading, is a diamond. Diamond is carbon. So carbon forms deep in the earth, and over time, the heat and the pressure make it into a diamond. Diamonds cannot be cut except with other diamonds. So they're used to make tools like drills and saws and things like that because they're super sharp. Calcite is one. It's formed in the ocean because of calcium and oxygen and carbon in the seawater. Galena is another one. It's hot water moving slowly through the cracks of the Earth's crust that makes galena. So calcite is the one that looks kind of milky, chalky that they have there. Then galena is the shiny one. You can see where it has the flat sides in a repeating pattern. Magnetite is the cool one, and usually I would show you magnetite in class, but magnetite is actually magnetic, and so things stick to it. Mica is the other one. Mica splits into these thin sheets, so it kind of comes apart really easily. Okay. Let me get questions. Braylon, you have a question?
Yeah. Is a diamond a type of metamorphic rock? A rock substance?
I don't know if it's considered a rock. I think it's considered a mineral because rocks are different minerals put together, but it is kind of a metamorphic process. Does that make sense? When we get into the rock part of it, after spring break, rocks are made of different minerals that come together. So this would be a mineral. All right, so let me get one more question. Gabrielle, you have a question?
Is coal considered as rock?
Cool. Let me Google it. Hold on. We'll Google it on my phone real quick. I think it's a.
Because if it is, wouldn't a diamond be considered? A diamond would still be considered as rock if it's made from coal.
No, coal is made from the dead plants and animals that gets heated and pressurized. So coal is classified as a sedimentary rock, it says.
Okay.
Although I think it should be metamorphic, but I don't know. All right, let me see. Addie, you have a question?
Yes, ma'am. What is the heading for these notes?
Just put Unit C, Chapter 2, Lesson 1.
I mean, but what is this talking about?
Minerals.
Oh.
C1, Lesson 2. All right, let me go through and get the people who have questions. Kylie.
For math, are we gonna have any assignments today?
Yeah, I'm gonna unlock it after this for you. Christian, you have a question?
Wait, so we have math?
There's kind of something wrong with my background. You can only see my eyes.
Okay, well that's not super important right now, okay? I can't find you guys after I unmute you. There we go. All right, let me get few more questions. Keller?
I forgot my question. Oh yeah. So when are we going to have a test on like the vocab?
I'll put it on Dojo, but it won't be until like Thursday after spring break. And I don't want you guys to have to study over your spring break. So if you guys have the next week to kind of study in the beginning of the week, I think Thursday will be good. So that'll be towards the end of April.
Okay.
20-something. Okay. Addie, question?
Yes. All right, so we're gonna have math homework and science homework?
Yeah, so you'll do that today, and then tomorrow I'm gonna give you something kind of fun to do for the day since it's before spring break.
Thank you.
No problem. All right, let me get down to Emmy. Question?
I thought we were in chapter 2.
Yeah, I meant C. Yeah, you're right. Sorry. C.
And isn't this lesson 1?
Yep, you're right. I get you guys confused with 4th grade all the time. They're in D1 actually. They're starting Unit D today. All right. Hold on. I have to remember to mute you guys after each one. Then I can't find you.
You can come here if you want to say
Jaden, question?
Like after all of this, you're gonna like Google my question, right?
Yeah, I will. All right, let me see. Christian, question?
Oh, dang it. I did it again. I forgot to put my hand down.
Okay, hold on. Let me unmute or mute you. All right, I'm gonna take one more question, then we gotta get going with the rest of this. Lily?
So are we still going to have class tomorrow?
You'll just have some stuff that I want you to do to kind of check in with me, but it won't be anything where you're gonna learn anything new tomorrow. So you won't have live Zoom tomorrow, no.
Okay.
because everything tomorrow is due by 3 o'clock. So I don't want to have Zoom with you guys at 10 and then have you guys rush all day to get everything done. All right, so look at the next page, C37. When you want to test a mineral, so if you have a mineral and you don't know what it is, the way you figure it out is you do some testing. So the first thing you can do is do a streak test. So what a streak test is like a tile. And it's like just a white tile. Think about like your bathroom tile, except not shiny. It's not finished. You drag the mineral across it, and then whatever color comes up, you can kind of look and see what it might be. The luster is another way. Luster is if it's shiny or dull. And then the hardness. Look at the Mohs scale. If you look at C37, that's your Mohs scale. M-O-H-S. It tells you how hard the minerals are, and then you test the mineral you're looking at and you kind of see where it falls. So if you look at the top, talc is a 1. So talc is the softest mineral there is. Talc is what they make baby powder out of, or any kind of powder that you might use is made of talc. It's really, really soft. If you find it, it crumbles in your hands. Gypsum is the next one. So gypsum is going to be harder than talc. So if we were to test it, a mineral with a higher number can scratch a mineral with the lower number. So if we found talc and we wanted to check it, we could scratch it with our fingernails or with gypsum, and if it scratches and something comes off on our fingernails, then we know that it's going to be softer than our fingernails. So a fingernail is a 2.5. So if you were to use your fingernail to test a mineral, your fingernail is going to be harder than gypsum and talc. So if you look at your fingernail, feel how hard it is. It's not super hard because you can tear those pretty easily. So that's going to be harder than talc and gypsum. Calcite and pennies are a 3. So you can take a penny and you can scratch calcite, gypsum, and talc. Fluorite is a 4. Apatite's 5. A knife is 5.5. Orthoclase and glass are 6. Quartz is 7. Topaz is 8. Corundum is 9. And a diamond is 10. So one way, this is kind of just like a fun fact for you, that you can tell if a diamond is real is if you have a diamond and you try to scratch a piece of glass. If it scratches the glass, then it's a real diamond, because a diamond is harder than glass. If it doesn't scratch the glass, then it's not a real diamond. Okay, so flip on over. How we use minerals. So without minerals, we wouldn't really have a lot of the things we have all the time. So you have questions? Hold on just a second. Let me finish this. Some minerals can be used in nearly the same form they have in nature. They don't need much refining or processing to remove other materials. For example, silver and copper can be used to make musical instruments, electric wire, and jewelry. Gypsum can be used to make plaster and wallboard. Graphite is used in pencils. Halite or table salt can be used to flavor and preserve foods. So if you look at the top picture in the light green, that's what silver looks like before they turn it into other things. So if you've ever seen silver jewelry, some of you girls have silver jewelry, or silver forks and spoons and knives. Your parents have really nice silverware, really silver, then that's what it looks like. So pure silver is really soft. If you ever have jewelry that is silver, it's pretty easy to bend sometimes. So because it's so soft, they can maneuver it and kind of make it into whatever they want to. The middle one is hematite. It is made of iron and oxygen. That's why it's so rusty colored. It makes steel, so it's really, really strong. The last one is a diamond. That's what a diamond looks like when they don't fix it up to make it look like what you think of a diamond looking like. So I always think if I were to find a diamond just laying out on the ground, I wouldn't know it was a diamond because that doesn't look like a diamond to me. So when you think of a diamond, like a diamond ring, or you think of the diamonds you see, anytime you think of a diamond, that is not what it looks like until they process it and they cut it and they make it look like it does in jewelry. The thing to the side is what they would use to drill deep into earth. That's the drill. And the little bits that you see on it that are raised up are diamond pieces, and they cover it with a silver paint. So this is what they would use to drill deep in the earth because it is hard. It's the hardest thing there is. It's a diamond. I think that's pretty much it. What you're going to do today is go through and you're going to read the lesson and do 1 through 5. I unlocked that this morning. If you look at the review questions, let's look at those real quick. The first one says list 3 features a material must have to be a mineral. We just did that. It's on your screen. So that's already the answer to number 1. What is a mineral hardness? So you would look back, and I think hardness, yeah, it's one of your vocab words. So you can just do a vocab answer for that. Name 6 ways people use minerals. We use minerals for all kinds of stuff. It's all on this page, C38. Number 4, you have a sample of an unknown material. It can scratch fluorite, but not quartz. What's its approximate hardness? So if you flip back to the Mohs scale, fluorite is a 4, quartz is a 7. So it can scratch fluorite, but not quartz. So that means it has to be harder than fluorite, but not as hard as quartz. Okay, so then you'll think about what the numbers can be. That one will have a scale of numbers. It won't be a specific number. And the last one, which is the hardest, we've gone over that. So you guys should know these. These are pretty easy questions for today. So what I'm going to do is unmute you guys, let you ask any questions. And if you don't have any questions, you guys can go get started for the day. So I'm going to unmute everybody at once. So remember, don't talk unless you have a question, okay? To be mindful for other people. All right, you're unmuted. Questions? Addie?
Yeah. So I have 2 questions. Would they use would there really be a process where they would use other materials besides what they have, like maybe other gemstones?
For what?
For like the same thing that they use for the Mohs hardness scale.
Oh yeah, you can put others on there. Because there's a whole bunch of others that go there.
And for number 3, where did you say we might get the answers from?
Page C38, where it says how we use minerals. It has all of those there.
Wait, you said 38?
Yes.
Okay.
Jaden, question?
What about questions about like the plates floating on the magma?
All right, let me look it up. For those of you for math, I just unlocked it, so it's there. All right, so Jaden, repeat the question so I can type it into Google.
How do the plates float on magma without the plates burning?
That's right. Okay, so how do plates float on magma without burning? Let's see what it says.
I don't
know. Let's see the chat real quick.
We're barking.
All right, so here we go. Hold on, I think I found.
Wait, we can leave?
Yeah, if you don't have any questions, you can leave and go do your math.
Okay, Miss Cart, I'm going to send you the corrections later.
Okay, no problem.
Bye.
All right, so here we go, Jaden. You ready?
Bye.
It says the mantle is not magma. Magma is partially molten rock, and due to heat, it behaves as a fluid. The mantle is very soft. It behaves more like plastic. It will slowly deform and allow movement, but is otherwise solid. The mantle is comprised mostly of silicate minerals rich in iron and magnesium. The crust, on the other hand, is mostly minerals that are not overly high in iron or magnesium. That doesn't really answer the question about burning. Hold on. I think it's something to do with what they're made of, and it says that if it doesn't react with oxygen, it won't burn. So some kind of minerals they're made of, it doesn't have parts of oxygen in it, so without the oxygen, it won't burn.
What about the faults?
The fault is just a break. It's just like a crack. It's complicated.
Wait. So if there's a fault, does that mean that's 2 plates right there?
Yeah. Mm-hmm.
So we're walking on plates right now.
Mhm.
So we're moving with the plates.
Mm-hmm.
What?
Earth is spinning like really, really, really fast in space and hurting in space, but we don't feel it.
Oh, is that why we feel earthquakes? Because we're
Earthquakes
standing.
is when they move. Yeah, so when they're moving really quick like that, that's when you feel the earthquake.
All right, I'm leaving.
Our ground.
Cool. Let me stop recording this too, because we're pretty much done with that.
Like a